To formally start, the first lesson is about Introduction to Statistics. In this lesson, you will not encounter any computations, so no need for you to get your calculators. All you have to do is listen to all the explanations about statistics and I would just like to clarify that in this presentation, I provided a concise description of each terminologies. So the meanings presented in this presentation is a bit different if you will compare it with the definitions written in your module. But rest assured that the meanings written in this PowerPoint and the meanings written in your or definitions written in your module means only one thing. Let's now start. The first term that we will discuss is about statistics. Statistics comes from the word state. I don't know if you already heard this one, but way back then, statistics is widely used by politicians for military purposes and other stuffs concerning the government. For example, census, or let's say they want to defeat another country. So what they're going to do is they will try to find out how many weapons do that country have, or what are their strategies, and from there they will form their counterattack. So in that simple way, they are doing what we so-called statistics. So when we hear this term, what does it really mean and how do you do statistics? So let us now formally define statistics. Statistics is a scientific process. When we say scientific process, it has to go through certain steps. Just like in your science subject, di ba, you have scientific process na you have to formulate a hypothesis, then you test if your hypothesis is correct through certain experimentations, then before you conclude. You cannot proceed with the conclusion right away without doing the or without formulating your hypothesis first and without experimenting. So you have to go through that series of steps before you conclude. So same with statistics. You have to go through a series of steps before we can conclude. That's why statistics is a scientific process. Next. Just like what I've said earlier, statistics is a scientific process. So, if it involves a scientific process, then it has to go through a series of steps. And the first step is the collection of data, wherein you have to collect information from whom? So, of course, from your respondents or from a certain database. Basta as long as you collect information or you gather information, you gather data, then that is the first step in doing statistics. The next step after collecting or gathering your data is the presentation. When we say presentation, it's either you place it in a tabular form, which is the usual way of presenting informations, or you can use different charts or graphs in presenting the data you have collected. Third step in the scientific process is the organization. So from the term itself, you have to organize your collected information, wherein you have to separate the informations you need for a certain computations and those informations that you don't need for a certain computation. Fourth step is the analysis. So when we say analysis, this is where mathematical computation takes into place. So the collected information and the organized information will be written in another numerical form, since we will now compute using those values. Last step is the interpretation of numerical data to obtain useful and meaningful information. So what I'm trying to say is that the numerical values that you obtained in the previous steps will now be interpreted. Now, for example, you reach this certain value, what is the meaning behind that value? So if you'll ask me, ma'am, how are we going to do that? We will just tackle it as we go along with the lesson po. Now that we're done discussing the definition of statistics, we will now define terminologies under statistics. The first term is population. When we say population, this is the entire number or group of individuals that you consider when you do the experimentation or when you do the research. For example, we have the senior high school as your population. So the entire senior high school is considered in your research or in your experiments. Since population is a large group of individuals, and in most cases we cannot collect or gather information for the entire group, so all we have to do is get a representative of that population, and that representative refers to the so-called sample. So the sample will represent the population, and that sample will be your respondents in a certain research or in a certain experiment. So this is just an additional information. The number that refers to the population is what we call parameter. And the number that refers to the sample is what we call statistic without S. So again, population is the entire individuals that you consider in your research or in your experiment. And then the actual respondents, the one who answers your survey form and such, is what we call your sample. So next, we have the parameter. Parameter refers to the number of the population. So for example, we have 100. 100 total number of senior high school is 100. For example lang. So 100 is what we call parameter. And then for statistic naman, for example, let's say your sample is the group of ABM students. So let's say we have 30 ABM students. So that 30 is what we call statistic. Next term is data. When we say data, these are the information that you obtain from your respondents, may it be their names, their age, or anything that has something to do with the respondents that describes your respondents is what we call data. Under data, we have the so-called variable. When we say variable, it is a parang distinction or a characteristic or a condition wherein those variables will be considered in the analysis and the interpretation part of your experiment or research. If you will ask me, ma'am, what's the difference between a data and a variable? Actually, data and variable is almost the same. It's just that for data, you have a large number of informations, and while in variable, it's just a specific ones. Parang variable is a type of data. Variable can be divided into two: the quantitative variable and the qualitative variable. When we say quantitative variables, these are the variables in which it includes numbers. Of course, from the term itself, quantitative comes from the root word quantity. So, when we say quantity, it refers to numbers. So as long as your answer is a number, then that variable is considered a quantitative um, variable. So for example, your weight, your height, your age. If you're asked what is your weight, you give an answer that is a numerical value, right? So meaning to say weight is a quantitative variable. Same with your height. So if you're asked what is your height, you do not say yes, no, or maybe, 'di ba? So you answer a numerical value for your height. That's why height is considered a quantitative variable. So for qualitative type of variable, from the term itself, qualitative, it comes from the root word quality. So when we're talking about quality, it includes words, phrases, and or sentences, or pwede ding paragraphs if it is applicable. So, in qualitative type of variable, you do not answer any numerical variable. So, for example, if you're asked what is your name, do you answer 1, 2, 3, 4, 5? No, diba? So, you answer in words such as, for example, in my case, what's my name? I'm Gracie. So, Gracie is a word. So, meaning to say name is a qualitative variable. Another example is your religion. If you're asked what is your religion, do you answer as 1, 2, 3, 4, 5? No, diba? Your answer is, for example, a Roman Catholic, or a Christian, a born again, or Iglesia ni Cristo, or whatever religion you belong to. So that's the example of a qualitative type of data. So now, if you will ask me, ma'am, can a certain variable be considered a qualitative and at the same time a quantitative type of variable? In some cases, yes, there are some variables that we considered a qualitative type of variable and at the same time a quantitative type of variable. I'll give you an example. Let's say we're talking about gender. Your gender is either a male or a female. But in some researches or in some experiments, they assign numbers to female, or they assign numbers to males. That if you are a male, you are number 1, and if you are a female, you're number 2, or vice versa. If you're a male, you're number 2, if you're a female, you're number 1. So if you will consider gender as male or female, then gender becomes qualitative. But if you consider gender as 1 or 2, then that gender is a quantitative type of variable. Another example is your religion. Your religion can be a qualitative type of data or variable, and at the same time, it can be a um, quantitative type of variable. So, for example, we just differentiate, or we just divide it into two as Roman Catholic and non-Roman Catholic. So if you're a Roman Catholic, you're 1. If you're not a non-Roman Catholic, we assign it as 2. So if you consider the Roman Catholic and non-Roman Catholic, then that religion is a qualitative type of variable. But if you would consider the numerical values that you assigned for Roman Catholic and non-Roman Catholic, then religion becomes quantitative type of variable. So it really depends on how are you going to interpret or how are you going to consider different types of variables. As long as you consider the numerical form, then that is a quantitative data. If you consider the words, the phrases, or the sentences, then it is a qualitative type of variable. Now, quantitative variables can be classified into two, and that is discrete and continuous variable. When we're talking about discrete variables, it represents whole numbers or finite numbers. When I say finite numbers, you cannot break them down into decimal numbers. Your answer is always a whole number. Sana all hindi nagbe-break. Charot. So going back, when we say discrete variables, these are the variables that your answer will always be a whole number. For example, how many individuals are there inside a classroom? Number of individuals is considered a discrete variable since your answer will always be a whole number. Kasi, for example, if you're asked how many individuals are there inside the classroom, do you say 3.5? No. Well, may manananggal kayo sa loob, but may 3.5? Diba? So, your answer will always be 3, 4, 5, 6, 30, 40, or any whole number. Another example is how many books are there in a shelf. So, books are considered a discrete variable since if you will count the number of books in a shelf, your answer will always be a whole number. So, as long as that given variable or the number that represents that given variable will always be a whole number, then it is a discrete variable. While in continuous variables, these are the variables wherein it represents a decimal or a fraction. Now, for example, what is your weight? Your weight can be 3.5 kilos, 49.9 kilos. So, if decimal and fractions are already involved, then you can say that that variable can be considered a continuous variable. Or another difference between discrete and continuous variables is that in discrete, we can obtain numbers by simply counting. For example, going back to my previous example, which is the number of individuals, you will just simply count the number of individuals inside the room and you can obtain the numerical value for that, as well as the books. You just simply count the number of books in total, then that will be the number that represents the number of books. While in continuous variables naman, you obtain them by not by counting, but with the help of an external object or an external parang thing that you use to measure that certain variable. For example, your weight. You cannot count your weight, but instead you use a weighing scale, right? So that weighing scale is the external object you use to measure a certain continuous variable. Another example for continuous variable is your height. Diba? You do not count your height, but instead you measure your height. So, if you measure something, then it is a continuous variable. But if you just count something, then that is under a discrete variable.